I wanted to go ahead and go into day number 2. I understand I did not explain day number 1 very well. Sorry, I highlighted this. So this is day number 2 of the Juleetcode. This is 1601, maximum number of achievable transfer requests. So I wanted to, first off, kind of show you guys the problem. And you can read it here. I need to stop reading these until I have caffeine because I'm so tired. But long story short, this is the solution I had, and when you run it, obviously it works. Hopefully still. Oh, please. Okay, yeah, it still works. So I submitted this, I think, the 2nd. Yeah, I submitted this on the 2nd. And this is how my solution kind of stacks up. So, I mean, it could be better, but, yeah. So, let's go into the breakdown of this. So basically, you have buildings, each building has a number of employees, and it's transfer season, and employees want to change buildings. That's it. All buildings are full. So, you have to have an equal number of people leaving and also moving in. So that the problem that this is trying to solve is to find the maximum number of requests that can be made, kind of like such that the net change of each building's balance is 0. Yeah. So the approach I took to this was this particular code uses backtracking to explore basically all the possibilities or combinations of selecting and not selecting requests. It maintains a variable max requests here, essentially to track the maximum number of valid requests found so far. And the backtracking function here takes 3 parameters. It takes index, it takes current requests, and net changes. The index is basically to track the current request index, cur requests to count the number of selected requests, and net changes to track the net changes in each building's balance. So the backtracking process is basically if index equals the length of requests, then it means that all the requests have been considered. And then it will check if the net changes in the building are 0, and if so, it'll update the max requests. So, and I don't know if that entirely makes sense to people. That's how my brain was thinking about it. So for the current requests at index, it increments from I, the building's net change, by -1 increments, and the to I index change by 1. Then it recursively calls the backtrack in the next index with current requests +1, and then updates the net changes. After that recursive call, it reverts the net changes made by the current requests by incrementing from I, and the building's net change, that'll implement the building's net change by 1, essentially, and then decrement the to I by 1. Then it also will recursively call backtrack, kind of like the same as above, and change the current requests and update the net changes. So the last kind of area is this backtracking process essentially just continues until all of the combinations of selecting and not selecting requests are there. The code basically initializes the net changes list with 0s for each building and starts a backtracking process by calling the backtrack with the initial parameters. So like index equals 0, cur requests equals 0, and net changes. So then finally the code will return the maximum requests, which basically represent the number of valid requests that can be made. And that's all I really got. I never submitted a solution for this, I don't think. Just because I don't entirely know that makes sense to people, but that's how I formulated this and targeted how I did this particular problem. And again, this is day 2 of the Juleetcode. This took me way too long to do, because I was like not doing it right. Anyway, so yeah, thank you guys so much for watching, and I will get busy on explaining day number 3, and then tomorrow we'll start back up with day number 5. Thank you guys for watching, and I will see you in the next video.